right, welcome to lesson 2 of chapter 6 on polynomials. Today we're going to talk about polynomials and linear factors. In the last video you learned about polynomials, what a polynomial was, how to name it, how to write it in standard form, and how to classify it. So we're going to keep going with that, but today we're going to talk about the actual factors in a polynomial. So our goals today are analyzing the factored form of a polynomial and writing a polynomial function from its zeros. We talked a little bit about zeros in quadratics last semester, so we're going to continue that. All right, so let's first talk about the factor theorem. So the expression x minus a is a linear factor of a polynomial if and only if the value of a is a zero of the related polynomial function. And remember, a zero is where that graph crosses the x-axis, so that'll be really important to us. So let's find some equivalent statements about polynomials. Here's our polynomial, x squared plus 3x minus 4 equals 0. So negative 4 is first of all, it's a solution of that polynomial. Because if we put negative 4 in here for x, we would have negative 4 squared plus 3 times negative 4 minus 4, and we want to know, is that equal to 0? Well, negative 4 squared is 16. 3 times negative 4 is negative 12. Minus 4, well, 16 minus 12 minus 4 is indeed equal to 0. So negative 4 is the solution of that polynomial. Negative 4 is also an x-intercept. So remember, if we put in, it should be a y-intercept, sorry about that. Pause. Okay, so negative 4 is actually a y-intercept of the graph, because if we put a 0 in here for both of these x's, we would get y equals 0 squared plus 3 times 0 minus 4, which is equal to negative 4. So our y-intercept would be at negative 4. Okay? Negative 4 is also a 0. So this graph would cross the x-axis at negative 4. All right, and then x plus 4 is a factor of the polynomial x squared plus 3x minus 4. So these are all equivalent statements. All right, let's keep going. So let's take a look at the graph of a polynomial. Remember when we were talking about quadratics, it was just like a U shape, and it either opened up or opened down, but a polynomial, it can go up and down several times. So there are different parts of the polynomial, or the graph of the polynomial, that we need to talk about. The first one is a relative maximum. Relative means it's related. So a relative maximum of this graph means the maximum y value in a certain region of the graph. As you can see from our graph, this is a relative maximum, but it's not an absolute maximum because the y values are higher here. So the maximum y value in a certain region. Remember, if you need to pause to write these down, please do so, because I'm going to go quickly. All right, a relative minimum is related to a relative maximum. It's the smallest y value, but only in a given region of the graph. So the minimum y value. in a certain region of the graph. Okay? So a polynomial may have a multiple 0. And a multiple 0 is just a repeated 0. And we'll get into what that means in a little bit. That'll have to do with those exponents. Okay? Excuse me. The multiplicity of a 0 of a polynomial function, I need my clipboard for this one, is a multiple 0 equal to the number of times that 0 occurs. Okay? All right, let's look at some examples. So the first thing that we want to do, right now this polynomial is written in factored form, and we want to write it in standard form. Let's remember that standard form means that we're writing all of the terms with the biggest exponent to the smallest exponent. Well, first of all, what we're going to need to do is that cool thing we like to do, foiling. But we have 3 terms here. So let's split it up and just deal with the first 2 terms first. So we're just going to look at these first 2 terms and we're going to FOIL. Remember, FOIL means first terms, outside terms, inside terms, and last terms. So if we look at the first terms, first times first, x times x is x squared. The outside terms, x times 3 gives us 3x. Inside would be -1 times x, or negative x. And the last terms, -1 times 3 gives us -3. And we can't forget that we have a whole nother factor out here. All right, so if we look at this one, we can combine some like terms. 3x and -x, if we combine those, we get just 2x. We're not quite finished yet, because now we have to essentially FOIL these 2 factors now, okay? So we're going to take x squared times x, and we get x cubed. Then x squared times 4 gives us 4x squared. Okay, so we shared this x squared with each of these 2 terms. We're going to do the same thing with the 2x. 2x times x gives us 2x squared. 2x times 4 is 8x. And then finally share the last term. -3 times x is -3x. -3 times 4 is -12. So we got rid of all of our parentheses. If we want to put it in standard form, we need to get rid of all the parentheses. But now we have a whole bunch of terms. So let's see what we can combine. Well, the x cubed only has an x cubed, so that stays all by itself. But we have 4x squared and 2x squared that we can combine to get 6x squared. We also have an 8x and a -3x. If we combine those, we get a positive 5x. And then we have our constant term here, -12. So this is our polynomial written in standard form. Keep in mind, the exponents go from biggest down to smallest. All right, so let's write a polynomial in standard form, let's put it into factored form. So we're just going to do the opposite of what we just did.